And welcome back to my channel. Here we have Bryant's Springboard with the M5 stamp C3 attached, and I'm still having problems with the springs. They're still a bit loose, but we've got to work out a way to keep them in place. Someone did suggest putting a little piece of wire underneath when you bend the spring back, and I might give that a try. But today I've made an addition to the board. I've soldered a 4-way connector onto the board, and the idea of that is I'm going to be programming it a different way to the average person. Instead of using the USB-C on the front, I'm going to go in via that connector here that I'm showing you. There it is, and it has ground, 5 volts, USB data minus and USB data positive, and so that is going directly into the chip, bypassing the USB-C and the USB to RS232 converter that's on the board. Here's the cable, USB standard connector at one end and a 4-pin header at the other, and we'll just plug that into the board, and then I'll be able to program it using any programmer I like. I shall probably be using the ESP32 IDF environment. Here we have the website for the M5 stamp C3, and we can zoom down and it tells you a bit about it, gives you a snazzy picture, a bit more description, and tells you what you can do with it, what it has, all that other junk. You can read this at your leisure. And then what I'm interested in is it talks about the ESP IDF. And so if you click on that, it takes you to the Espressif page, and we've got the ESP32 C3, and it's all about getting started. And what I've done, because I don't want to work the same way as other people, as I find that not as interesting. So basically you'll scroll down here, and you can use the Eclipse plugin, or you can use the Visual Studio Code extension. What you want to do is click on the Windows installer, download the code, get on there. It tells you all how to do it, how to launch it, download it, run this, and this is what you end up with, which is pretty much what you need if you're going to do what I'm going to do. So we come down, and the important things are, you can start off by just doing the hello world, but that's not a very good one. So I started off by doing a blink, and what I did was I copied, instead of doing hello world, there is in their examples at getting started, there's a sort of simple program that, or a sample program. It's got what you need to create your own program, and so you just change that to like sample program and then call it blink, and what will happen is up will pop the program for you. And then you need to go to the directory where you've put it. You definitely need to do the idf.py set target ESP32 C3, because that tells the compiler the chip that you're using, and it will get its knickers in a twist if you don't. And if you're going to use parts of the program that can be configured via the menu, then you can run that menu command to go into the menu, and it tells you here like how to get in here. But I'm not going to bother, because I'm not going to use the options in here. So I'm just going to use the idf.py build. But you can get away with it. If I go down further, you can do the idf.py -p port flash, and this will build it and then flash it, and you just change the port to like COM and whatever port yours is set to. So I hope that makes sense, and we'll show you what's happening. All right, so you can see here, I've copied I'm going to copy from the IDF path examples, get started, the sample project, and I'm going to call it blink. And so we hit return, So we can go into it. Spell it right. And see what it's put in. It's put in some directories, by directory, and a make list. And if we go into main, my fingers aren't doing what they should do today. And we have a main.c. Now what I'm going to do now is I'm going to open main.c. You won't see me doing this, but I'm going to open it. I'm going to show what's happening in Notepad. Here we are in Notepad, main.c. So basically what we need to do is fill this in. And the best way to do that is to just make it up as you go along, I suppose. We're going to use a few includes, and just for the sake of making it a bit quicker, I'm going to paste them in. And then we'll talk about some of them as we go. Now we want to, if you're used to using the Espressif IDE or the IDF, then you can send messages out using the RS232. And what we do is we have a static tag, and we'll call this blink. And what will happen now is every time we send a message using the Espressif serial print routine, it will tag it with blink. It's a very good system to use if you can, because you can get it to highlight the difference between whether you're sending it a normal message or an error message. So the next thing we'll know is we want to hash define an IO port. And the way to do this is you'll notice that there is a Gpio.h, and if we go to Gpio.h, it tells you all how things work, how to configure, how to reset a pin, how to set interrupts. But it also, you'll see, it links to Gpio_types.h, and if we go to the _types.h, you'll see down here there's an enumeration for the pins. So if we want to use pin 8 as an input and output, we can just go and copy that, and then we know we're going to have the right pin number. Next, we want to configure. We'll set a message up so that we know we're about to do it. What we'll do is we'll define a routine to configure the LED, and it will be a static void because it won't return anything. Configure LED. It won't take anything. And then basically we're going to use the ESP_log I, because log I is log information. And then we're going to use our tag, and then we're going to say blink configured to blink Gpio LED. So that will send the message out, and now we want to reset the pin. So Gpio underscore reset pin Gpio. So that will reset it, and then we want to set the direction and mode, and we do this with the Gpio set direction. Then we need to do the blink, the address of our port or the port pin number, and Gpio mode output. So this is very much like you do with the Arduino when you set up a pin. This is just a little bit more complicated, and you need to look at the includes to work out exactly what you're doing. And then you want to blink it. So we need a program, we need a routine to do that. And it's a static void and it doesn't take anything. So we're going to watch my bad typing again. And we're going to set the Gpio level according to the state. That's going to be low or high. So we're going to do Gpio set level maybe I'll take a mouse off the keyboard and do that, and then we're going to use LED state, but we haven't got one of them yet, so we're going to have to define one of them, aren't we? And that's that done. So we're going to have to go up here and we're going to have a static uint _t LED state equals 0. We'll start with it off. So we're nearly there. We just need something now to call these. So we're in there and we want to call the configure LED function, and then while one. Right, so while it's on, we want to do a I want to send a message to say when we're turning the LED on or not, just in case we can't see it. We'll send it a string. And what we'll set is LED state, and we'll compare it to true, and then we'll do the magic question mark. If it's true, it will send on to the print statement, and if it's not true, it will send off. It's a good little command, that, the question mark, for doing sort of simple tests. And then we want to blink the LED, and then we want to change my fingers don't want to play game. So we'll invert the LED state, and then we want to pause. We don't want to go on off so fast you won't see it. We want to pause, but you cannot go delay, because if you do delay that's longer than time that the ESP needs to do something, it will crash out. But we're using the RTOS, the free RTOS, and so basically we put a delay in via vtask. So this doesn't block the program from running. It blocks our program, but the tasks underneath can carry on. So we'll define a blink period and we'll divide it by port ticks in milliseconds. So that basically means if blink period is 1000 milliseconds, that will be a second. Oops. So that's basically it. That goes there, and then we need another one there. We lost one somewhere. We'll pop that one in a bit. Same as that one, we'll pop it in a bit. Oh, no, we didn't do that one. Let's get rid of that. So it's happy. Right, then we'll pop that one in a little bit just to show it's indented a bit. And we need a blink period. So we'll go up here and we'll define a blink period of, I don't know, 500 milliseconds. There. And we'll save that. Right, the next bit is we have to tell the compiler that we're going to compile a C3 chip. So it's idf.py set target ESP32 C3. And away it goes. And I've not put it into blink. Not a good day today. So now it should go. And away it goes. And it will trundle along for a bit. So that's done that. So now, if we want to build it, it's idf.py build. And as you can see, this is going to take quite a while because these numbers are going to count up to 809. So we'll just sit back and watch it go. We may have to speed it up because I'm sure you won't want to watch all this going. Oh, we failed. And what did we fail on? Any errors? Oh, this will be a fun one to find, isn't it? Where did it first go wrong? Oh, I didn't see that one coming. So, let's see if we can work out where it went wrong. Let's go back and have a look at here. Oh, did I spell define wrong? Oh, look at that. That's a pretty common mistake, isn't it? So it would have complied against all the blink GPIOs. This is part of the fun to debug things. Right, so that's done. So we've got a problem with our log level. So let's go back and look at our log. We called it blink. That one looks okay. That looks okay. Tag, comma, comment, close speech marks. There's the next one down here. Turn the LED, comma. That one looks all right. That's anything to do, isn't there? So we'll try again. We'll try building it again and see what happens. Still doesn't like it somewhere, does it? Where's it first going wrong? I expect something, but it's not getting it. I need to go and scratch my head on this one, I think. Well, I had a quick look around here. Couldn't quite find out what it was complaining about, but just checked again, cleaned it up maybe, and we'll try again. Let's go back to the build, see what happens this time. Well, there we go. It built. There must have been a bug in there that I didn't quite see. I'm just typing it again. I could go back there at a point and have a look. Right, as you can see, I've got an LED connected between G8 and ground. I have a switch connected between G9 or Gpio18 and ground and the USB lead. Now I press the button and click on the reset or enable, and that puts it into reset mode, and the port's ready for programming. So now I can give the command to flash the chip. Which is, IDF.py-p command com6 flash, and away it goes, and it is flashing now, and that's the flashing finished. So all we need to do is press the reset button to make the chip run, and there it is, blinking. So successful. And just for a quick one, we will load the monitor. And this is just to show the effect of the output. So as you can see here, you get the tag saying blink and the turning LED on, off, on, off. So if you'd like to see more of this, hit the subscribe button, ring the bell, and I'll catch you on the next one.